All right. Good afternoon, everyone. So the video today that I'm going to make is just going to expand a little bit on what we talked about in class yesterday. Obviously, I know we only got through the very, very beginnings of linear regression and what you're going to be expected to know and be able to talk about. Also, losing power for like 5 minutes didn't really help yesterday, but that's fine. So really where we left off yesterday was we talked about R, and we talked about how that's called the correlation coefficient, right? So oftentimes what you'll see in terms of a question or a free response question is they will ask you something along the lines of, right, describe the relationship between X and Y. Right, fill in the blank for the context of X and Y, right? Actually being your explanatory variable and your response variable, to use the terminology that we learned yesterday. So when you see that question, immediately what you do is you look at the R value, right? What is R? What is my correlation coefficient? That's going to help me here describe my relationship, right? And when you see that question, we're thinking of three things, right? Not really another acronym, but three things that we need to talk about, right? Strength, form, and direction. Those are the three main things that I want to make sure that I talk about. So for strength, we have two options here. It is either strong or it is weak. There is no in between. There is no moderate strength. There is no middle ground. We are either strong or we are weak. Now, usually the cutoff to determine this, right, I usually just use 0.5. Anything greater than 0.5 is strong. Anything less than 0.5 is weak. Luckily for you guys, it will be pretty obvious from the question. You'll see an R value of like 0.85, right? They're not going to give you anything, or at least I shouldn't say that. I haven't seen any question where they give you an R value of something like 0.47 and it's like right on the edge and you got to like think about it and oh my goodness and sweat about it. So usually it's either really, really high or it's really, really low. So usually it's not a big concern to worry about. However, just as a general guidance, I would use R equals 0.5 or negative, right? So I guess if I'm being specific here, I would use plus or minus 0.5 there as my cutoff, right? Obviously, remember, the closer to 1 or negative 1, the better. Form, luckily for us, and we talked about this a bit yesterday, we are either linear or we are nonlinear. That is it, right? We don't worry about, oh, this could be quadratic or this could be cubic. Nope, we are just linear or not. Now, we will talk about how to determine this because R isn't always necessarily the best indicator of whether or not something is linear. However, it's very, very closely related, right? If you have a strong relationship, considering we're only using lines, that is going to be a strong linear relationship. Right? And then direction, obviously, we're only looking at positive or negative, right? So here that is describing both slope and our R value, right? Obviously, if R is positive, that means my slope is positive. If R is negative, that means my slope is negative, right? So, for example, right, let's say I had an example where I had a regression line. We'll talk about why the hat is there. That's like 2.7x minus 14.6. And I gave you an R value, let's say, of 0.84, right? And for the context of this question, let's say x is, I don't know, the number of donuts somebody ate. And Y is a happiness rating, right? So based on this relationship, right, the more donuts we eat, the happier we are, right? So the way that I would describe this relationship based on my R value and based on my slope here, I would say there is a strong positive linear association. That's not how you spell association. There we go. Association. Is there a I don't know how to spell. It's fine. Between the number of donuts eaten and happiness rating. Boom. Right? So pretty much, you notice we would say there is a fill in your blanks of strength, direction, form, right? So fill in your blanks when you say there is a, fill in those three things. And then we insert our X and our Y variables here to give the problem context, right? So when I say this, I get the context point. Now, the other thing you do want to make sure you talk about, if it exists, are any sort of unusual points or outliers. So we do want to make sure if there are those things, we talk about them. We will talk more next time I see you guys, so probably Wednesday next week, about how to determine whether or not something is an outlier, because unfortunately with regression, it's significantly more difficult to determine whether or not something is an outlier. It's not as easy as with a box plot or with a histogram. So we do want to make sure, right, if there is one data point that's like really far away from the rest of them, that we do mention that that is there, right? So the next thing that I want to talk about is R squared. Now, R squared is literally as simple as taking whatever your R value is and squaring it. But R squared has a different name. R squared is called the coefficient of determination. That's a D. There we go. Right, so sometimes you may see a question where it asks you to interpret the coefficient of determination. Right? Obviously, when you see that, we're thinking R squared. And now there's a very, very formulaic answer to this question. And that is, here's our fill in the blank, right? So if the example is to interpret the coefficient of determination, right? I'm just going to abbreviate that here. That's our question. Here is the response. Every single time we are going to say, whatever I put in green, we'll say here, we're going to fill in the blank. R squared percent of the variation in Y, fill in the blank, can be explained by the variation in, again, fill in the blank, X. Now, obviously here, R squared is your actual number, right? So let's say, for example, R was 0.9, R squared would be 0.81, right? It is as easy as take R and square it. That is your value. Sometimes that's important to understand that, because sometimes you may only be given R squared, and they may ask you to work backwards to determine what R is and then interpret that. So it's important to know that. Y and X here are just the variables from your question, right? Y being my response variable, X being my explanatory variable, but the idea being in the context of the question, right? If I go back to this donuts and happiness rating example, if I square 0.84, let's just call it 0.7, right? 70% of the variation in happiness rating can be explained by the variation in the number of donuts eaten, right? It is as easy as take those variables and fill in the blank. So that is all that I wanted to focus on for today. I didn't want this video to get too crazy long. I'm going to leave a very short free response question for you guys, so just so you can get an idea of what types of questions is College Board going to ask you about R and R squared, as well as just linear regression as a whole. So I hope you guys have a wonderful weekend. Please turn that FRQ in just so I can give you guys some feedback so you can see whether you're on the right track or not. And I will see you all next week. Bye, guys.